All right, you know the problem. There are 9 horses. You get to choose any 3 of them, and if any of those 3 win the race, if A wins, B wins, or C wins, then you win. Then you just win. If D wins, E wins, F wins, G wins, H wins, or I wins the race, then you lose. Well, since all those horses have an equal chance of winning, we know it's going to be 1/3. But let's do this let's start with combinations, let's say. So we could say something like, how many different ways can we choose 3 from the 9? All right, and that would have been 9, 9, choose 3. Now, of those 9, choose 3, how many different ways can we choose these so that I would be a winner? So let's just say horse A wins. Okay, that means how many different ways can you choose this so that A will be amongst those 3? Well, probably the best way to do it is to say, well, how many ways can you choose it so that A will not be amongst those 3? Simply be 8, choose 3. In other words, you just have to choose any 3, but you can't choose 8. So there's 8, but you can't choose A. So there are 8 different things you could choose 3 from them. So that's how many ways that A will not be included. And that is out of 9, choose 3 total ways that you can choose. And if A is included, you win, right? So this is the number of ways to lose. And this is equal to 8 factorial over 3 factorial, 5 factorial. This is divided by 9 factorial over 3 factorial, 6 factorial, which equals, so you're going to, this is going to be 8 factorial, this 3, that can come up here, times 3 factorial, 6 factorial, divided by 3 factorial, 5 factorial over 9 factorial. This 8 and this 9 cancel, except you're left with a 9. There's 3 and this 5, or sorry, this 3 and that 3 cancel. You're left with a 5 and a 6. 5 factorial cancels all of the 5 except for the 6, and it is 2/3. So you have a 2/3 chance of losing, which gives you a 1/3 chance of winning. The other way to do it is just say how many of these combinations are actual winners, like A is included. So that means that you have to combine A with any 2 of the other 8. Right? So how many different ways can you do that? Well, it's going to be, you have to just take 8, choose 2. So 8, choose 2 different ways to combine this A with 2 others. Basically, you have your A, and you're saying, like your A, you're saying is a winner. That's the only way to have a winner, is if A is in there. And it can be combined with any 2 of those 8. Right? And so that is going to be equal to 8 choose 2 is 8 factorial over 2 factorial, 6 factorial, divided by 9 factorial over 3 factorial, 6 factorial. So, of course, that's like 8 factorial over 2 factorial, 6 factorial, divided by 9 factorial over 3 factorial, 6 factorial, which is the same as times 3 factorial, 6 factorial over 9 factorial. This 9 factorial, most of it cancels out. 8 factorial will cancel all of the 8 except for 1 9 left. These 6 factorials will cancel each other out. 2 factorial will cancel most of the 3 out. And you're left with 3 over 9, which is 1/3. All right, so that's 1/3 of the time this A will have been chosen. All right, let's try and do the same thing with straight up factorials. So since there are 9 factorial different ways that you can arrange these horses. Since, let's call A the winner, right? We want to know the probability that A will be one of our 3 chosen. So we'll just go through all of these 9 factorial different ways of doing it and see how many would be chosen. So you could have A in front with 8 factorial different things, and that would be a winner because that was one of our chosen. So it's 8 factorial different ways. Or you could have A in the second position with 8 factorial ways of rearranging the others. So it's plus another 8 factorial. Or you could have A in the third position, and that would be plus another 8 factorial. You could do that and just say 8 factorial times 3, or if you had done it with, well, what are the chances of losing? Well, that's if A was in the 4th, 5th, 6th, 7th, 8th, or 9th positions. So you'd have 8 factorial plus 8 factorial, 6 times, right? 8 factorial plus 8 factorial plus 8 factorial, all over 9 factorial. So this is the probability of losing. This is the probability of winning. All right, well, 8 factorial plus 8 factorial plus 8 factorial equals 3 times 8 factorial. This is over 9 factorial. Of course, this all cancels out, and you're left with a 9, and that's 1/3. Here we have 6 times 8 factorial. So you got P of losing, the probability of losing, is equal to 6 times 8 factorial over 9. And of course, this all cancels, or over 9 factorial. This all cancels with that, and then you end up with 6 over 9, which is 2/3. Okay, that is using just straight up, no permutations, no combinations, just straight up factorial. All right, let's try permutations. All right, for permutations, we're going to say, let's say we choose A, B, and C. All right, or let's say, how many different ways can we choose 3 horses, any 3 horses, okay? So that means we can choose, A, B, C. We could actually, let's say order matters this time because we want to use permutations. So now we got B, C, A, we got B, A, C, and we got C, A, B, and we got C, B, A. Okay, those 6 just for that. But you could also do, like, of course, you got D, E, G, and G, I, H. And there's like a whole bunch of different things that we could have chosen, all right? And so the number of them is 9, P, 3. We got 9. We're taking 3 of them, and order matters for those 3. All right, so of those, how many will be winners? So probability of winner. And we'll also do all those, how many will be losers? Probability of loser. And that's going to also be over 9p3. So we're going to, of these 9p3, we're going to say how many are going to be winners first. So anything where A is inside that thing. So A doesn't have to be matched up with B and C, because if horse A wins, no matter what horse wins, if you have that horse inside your thing, you're going to be a winner. So A doesn't have to match with B and C here. It can match with any 2 letters. So let's find 2 letters how many different ways can I match 2 letters with A? All right, well, there are different ways. So you can choose A in the first position, and then any 2 letters can go with it. So we have 8 letters, and we could choose any 2 to go here with the A. So we're going to say this is going to be 8P2. That's all the different combinations of putting 2 letters here, and that includes like D, F, and FD, right? We're not ordering them, or sorry, we are ordering them because we're using the permutations. But that's A in the first position. Okay, so this is 8P2 is all the different ways to choose any 2 letters that aren't A to go along with this A. And the order of the other ones, basically this number is going to be like, let's say I choose B and C, and then all the different combinations of D, E, F, the order doesn't matter. Okay? And so that's with A in the first position. But A could also be in the second position, so you're going to have another 8P2 ways with A in the mix of it, and then you're going to have a third way of 8P2 with A in the third position. So this is all the different permutations with A included in those permutations. And there are 9P3 different possible ways to choose any 3. Of those 9P3, this is the number where A would be included. Okay? And so that is equal to, well, this is our P of W, first of all. That's the probability of winning. And that's equal to 8, so 3 times 8 factorial over 6 factorial, which is 8P2. And the bottom is 9 factorial over 6 factorial. These 6 factorials can cancel each other out. You're left with 8 factorial over 9 factorial times 3, so this 8 factorial cancels out almost all the 9 factorial. You got 9 left. That's 3 ninths. You got 1/3. There you go. All right, now let's say the losers. How can you find the losers? So losers means you cannot choose A. So you have 8 different things to choose from, and you need 3 of them. You need 3 of them, and none of them can be A. So you have 8P3 different ways of doing that. And that is over 9P3. Right? So this is the number of different ways where A would not be chosen, because I took the other 8 and found all the different ways to choose any 3 of those. And this is any 3 being chosen. Right? So 8P3 is going to be 8 factorial over 5 factorial. 9P3 is 9 factorial over 6 factorial. That is equal to, sorry, everything's all over the place, but I figured you wouldn't care. 8 factorial over 5 factorial times 6 factorial over 9 factorial. This 6 factorial, so the 5 factorial can all go away, and you're just left with a 6. The 8 factorial all goes away, and you're left with 9, and that equals 2/3. That's the probability of losing. All right, let's try this in a different way. Let's say we definitely chose A, B, C, D, E, F, G, H, I. We did not choose D, E, F, G, H, or I. So what is our probability of winning knowing that we chose A, B, C exactly? Well, 9 different horses can win, right? So I has a 1 in 9 chance. H has a 1 in 9 chance. G has a 1 in 9 chance. F has a 1 in 9 chance. Okay, so the probability of any one of these guys, the probability of I winning is equal to 1 in 9. The probability of H winning is equal to 1 in 9. Probability of G winning, I think you're getting the point here, 1 in 9. The probability of A winning is 1 in 9. Probability of B winning is 1 out of 9. And the probability of C winning is 1 out of 9. Looks like 6 of those, if any of these 6 win, that's considered a loss. So the probability of loss is all of these guys added up together. So I didn't do D, E, and F, but you get the point. D, E, and F. So the probability of losing is when any of these guys win. You just add up 1/9, that's 6 ninths. And of course here you got 3 ninths. Probability of a winner.